Okay, hi there. So we're starting off in a new section today, and we're going to start off with the idea of something called functions. Okay, functions. And what functions are, think of the word functions in English. What does a function of something do, right? Whoops, I should have said it a different way, but it does something, right? What's the function of this tool? If I show you a pencil, what's the function of a pencil? It writes, right? It allows you to copy notes, it allows you to mark down on a piece of paper. So what's the function of a toilet? It flushes water down and away so you can get rid of excrement. What's the function of a stove? It makes food from raw food to cooked food. It can make regular temperature water to boiling water. What does a fan do? It pushes air around. A function does something. This does something. And math people just call them functions. What did you do to a number? So if I say the function is, let's look at it a couple ways. There are ways of writing functions. Y is equal to x plus 2. This is our y method, just using y as our output. Or we can write f of x. This is the letter f. Let me just erase it. F of x. So maybe in 8th grade you've seen this before, but the idea is these two ways of writing a function are actually the exact same thing. They mean the exact same result. And we'll talk about today what the difference is, and definitely they are similar and they're pretty much the same, and just notation's a little different. So we're going to create a table, an x and y table. Whoops, still on the left. Our x and y table, and our x and f of x table. And what we're doing is we're logging what does this function do to my problem? How does it change my initial value, my input value? So we can add some notes here. X is always considered for us your input value. And Y is your output value. This is the result of the function. X is your input, and f of x is your output. So if I plug in numbers 1, 2, and 3, well, x is now 1. So when I write y is equal to x plus 2, we said x is now 1 plus 2. We swap our x value because we said x is going to be 1. That becomes 1 now. X here is 2, so it's 2 plus 2. X is 3, 3 plus 2. If you notice, instead of writing x, I write what x is now, what number that is. So we do the math. So what is 1 plus 2? 1 plus 2 is 3. So when I plug in x is 1, our output is 3. If I plug in x is 2, our output is 4. When x is 3, our output is 5. Another way of looking at this is let's do each of these problems separately. If x is 1, y is equal to 1 plus 2. See, x is now 1. And 1 plus 2 is 3. And that's really what we're demonstrating here in a faster way. If I plug in 2, y is equal to 2 plus 1 because x is now 2. So 2 plus 2 is now 4. Our y value is now 4. So a table allows us to organize our values a lot faster without having to write everything over in this messy way. So what does this mean for us? Well, given the function y plus 2, sorry, whoops, y equals to x plus 2. We can show this on a two-dimensional graph. The two-dimensional graph, we call it x and y. And the x and y pretty much says your input values. If I input x, what y value comes out? So let's go back and look at our table. We said when x was 1, our answer y, oops, if x was 1, our answer y was 3. So let's go back to the table. When x is 1, 2, 3, 1, 2, 3, I'm gonna label this 1, 2, 3, 1, 2, 3. If x is 1, y is, we said what? Y is 3. When x is 2, y is 4. When x is 3, y is 5. Now, we label these points in a special way. It's called an ordered pair. So we said the first one was 1, comma, 3, then 2, comma, 4, and 3, comma, 5. These are called ordered pairs. An ordered pair is 2 points where we have an x and y. So if I say 1 and 3, the x value is 1, and the following value, the next object, is our y value 3. And why do they call them an ordered pair? It seems kind of lame, but the reason why is this is not the same as 3, comma 1. If x and y are an ordered pair, 3, comma 1 is actually a totally different position. 1, 2, 3 x's and 1 y versus 1, 3. X is 1, y is 3. These are totally different points here. It's like your first name and last name. If I call out, my name is Edward Coe. If I go Coe-Edward, hi, my name is Coe-Edward, people would think my first name would be Coe and my last name would be Edward. So an ordered pair is a way for us to all agree that x's come first, followed by y's. Now in algebra, it gets confusing because there's all these different ways of representing the same thing. We can represent it as a graph. That's the same thing as our function y is equal to x plus 2. We can represent it as our table. That's our input-output representation of our function. We can just write y equals to x plus 2. So people get confused because there's all these different ways of representing the same thing, whether visually as a graph or tables as numbers. Now, we'll come back to the function representation in just a little bit, but let's do another function. Y is equal to 2x minus 1. Y is equal to 2x minus 1. Now, this is my function machine. It changes x's to become y's. Oops. It changes x's to become y's. Okay. Now, in real life, we have functions for people like you. The example is, if you want to get stronger, what's something you can do? What's a function you could do? Pumping weights, right? Couldn't you go to the gym and work on machines and those would make you stronger? What if you want to call your parents, right? What if they're not home? What do you use to then call them? Use a cell phone, and that in essence is a function. It takes your voice from your house and it does something to it and it sends it across the universe to your family, wherever they are, maybe in the next city. Now, I gotta tell you this, functions are actually the basics of all you do and everything in your life. Your cell phone actually uses functions in the math when it uses it to transmit the signals across. Your microwave, your car, when it comes to how much gas you press down versus how much output in speed. When you breathe, that's a function also, how much air comes in and how much air goes out. So everything, there's a relationship. And that's another way of thinking about a function. A function is just a relationship between x's and y's. Okay? A function is just a relationship between x's and y's. If I plug in so many x's, what happens? What y do I get out? Imagine when you eat a food you like. The function, you become happy. But what if you eat a food you don't like? The function changes it to be a bad experience. So here we go. Let's talk about this one. We'll do x and y's real quick once again. So we're going to plug in the numbers -1, 0, and 1 this time. We're going to plug in 3 different numbers. And as we practice this, I want you to write it out. So our y value here is, just to remind you, it's 2x minus 1. So our function is going to change our x to become our new y value. So the way we do this is I'm going to write 2 parentheses minus 1, 2 parentheses minus 1, 2 parentheses minus 1. I want you to do that right now 3 times on your notes. Do this right now on your notes. Okay, x is -1. It's the function. It's going to do something to it, and I'm going to get my new y value. So another visual way of looking at this is if I write 2x minus 1 here, if I plug in the x, what y comes out? So we'll just look at it one way and we'll go back to the table. If I plug in -2, 2 times -1, whoops, minus 1. This is -2 minus 1 is -3. So when I input the x value -1, my y output becomes -3. So it changed it. So we're going to do this 3 times now. We're using the same function. The function is 2x minus 1. And we're going to plug in x is -1. We're going to plug in x is 0. And we're going to plug in x is 1. So please notice that all the x values, I swapped them out. Instead of writing x, I just wrote the number instead. So what happens when I plug in -1? -1 times 2 is -2 minus 1 gives me -3. The y value is -3. When I plug in 0, what's 2 times 0? 2 times 0 is 0 minus 1 is -1. What is 2 times 1? 2 minus 1 is +1. Now, let's see what happens when I graph these points. So let's write the ordered pair. So for my first one, if I plugged in -1, what was the y value? What about when I plugged in 0? What happened to my y? How about when I plugged in 1? What happened to my y? What was the y value that came out of these? So my ordered pair is always x first, then y. Always x first, then y. So I plugged in -1. We got the answer, -3. When I plugged in the number 0, we end up with our y value, -1. When I plugged in my 1 value, right, our y value was 1. So an ordered pair is almost is that solution set. What happens when I plug in x? What happens when I plug in a different x? What happens when I plug in a different x? And these are the y's are the results. These are my output values. So on the graph now, I can graph it. X is -1, -2, -3, like a number line, 1, 2, 3. We put 0 right in the middle. So these are my x values and my y values in the x direction and the y direction. So remember, x is my input. Now, where would the output fall? An output could fall anywhere. It could be a gain. I could be making money. I could be losing money. And that's our idea of our y. So what is the result? So let's take a look. When x is -1, so I'm looking at -1 here. What is the y value? -3. So x is -1, y is -3. Let me graph that with a different color. So if x is -1, here is x is -1, okay? But where does the y value go? It doesn't go everywhere. It just wants it at -3. How about our next point? 0, -1. At x is 0, here is x is 0. Where's my y value? It's specifically only at -1. And our x is 1, our y is 1. Now, our following observation is that, look at those 3 points. Do they look like we could follow that pattern? Could we follow that pattern? And we can. Let's see, let's use. And what happens is this line here is all the possible patterns. The line represents all the possible patterns. What if I plug in 2? What do you think the y value is going to be? If I plug in 2, doesn't that look like 3? What if I plug in 3? Okay, so all this line means it's all the other possibilities. It gives me the pattern. So if I plugged in, just to check, if I told you plug in 2 and plug in 3, do we get 3 and do we get 5? Let's try it. Y is equal to 2 plug in 2 minus 1. So this is my input was x equals to 2. What's my y output? Y is equal to 4 minus 1 is 3. Yeah, we said our point here was 2 comma 3. So this is without us doing the math. We're just doing the math to check. If I plug in 3, y is equal to 2 times 3 minus 1. Y is equal to 6 minus 1 is 5. Hey, that's what we just said. We said 3 comma 5 was my next possibility. Okay, so as we first start looking at these patterns, well, we want to learn a couple of new words here. And the idea here of input, output, and output are going to be replaced with math words called domain and range. So think of these words in English. Like domain is where you stand. Okay, your range is how far you can go. Domain is where you stand, and range is how far you can go. What's your range? Okay, so this is another way of saying x's and y's, your inputs and outputs. So let's give us a quick idea here. If I give you guys this table here, an x and y table of 0, 3, 5, and 1, 4, let's do 7. Okay. Your domain and your range. Well, that means for all the inputs here, my possible outputs are here. So all they're saying is the domain and range is your inputs and outputs. What possibilities do we have for input and what possibilities do we have for output? So domain and range, they usually draw them in like boxes. And if I say, what x values do you see here? I see the x values 0, 3, and 5. What output values do you see? I see the values 1, 4, and 7. And we're going to visually draw a relationship. 0 goes to what number? 0 goes to 1. What numbers does 3 go to? 3 goes to 4. What number does 5 go to? 5 goes to 7. Okay. Let me give you guys one that's a little bit different. Here's my x and y. I'll draw these a little bit smaller. 2 to 1, 3 to 4, and 4 to 1. Domain and range. What numbers do we see for domain? We see the numbers 2, what else? 3, and 4. These are my possible values for y. So for x. Now, look at the y values. We actually have repeating values, don't we? So I see the 1 happen twice. The range is only 1 and 4 because the 1 repeats itself. So we don't have to write a 1 again. These are just possibilities. It's almost like a menu, right? Sometimes on the menu, you have repeating items. You might see chicken 3 times, right? So these are our possible combinations. So when 1 goes to what? 2 goes to 1, draw an arrow to 1. Where does 3 go to? 3 goes to 4. 3 goes to 4. But where does 4 go to? 4 goes back to 1. So let's use representations of locations instead. Let's say 1 is your home, 4 is the mall, and 1 is your home, right? They'll say 1 is your home. So I want you guys to look at it a different way. Each input only has one output applies to the function. So for something to be called a function for us, yeah, every input has an output, and every output, but for functions, we're going to learn this a little bit later. There's a rule for it that you can't double up on your input. Like you can't repeat domains. And I'll show you that in a little bit with this example. So think of this as time. At 2 o'clock, where are you at? You're at home. At 3 o'clock, where are you? At the mall. At 4 o'clock, where are you back at? You're back at home. Right? So it kind of makes sense. At 2 o'clock, I'm at home. At 3 o'clock, I went to the mall. And at 4 o'clock, I'm back at home. So the function is almost like a car. It's driving you around town. Okay? And we're okay to do that. Our range here can repeat because I can be at home multiple times. But here is a caution. Here is a caution for functions. Not everything is what we call a function. Some machines don't make sense. So here's a machine that doesn't make sense. If I write 1. So let's do 2, 3, and 2. And let's do 1, 2, 3. Okay? We're at home. We're at Target. And we're at school. Let's see if this makes sense at all. And this is our time. At 2 o'clock, we're at home. Makes sense, right? At 3 o'clock, we're at Target. And at 2 o'clock, we're at school. But didn't you just tell me at 2 o'clock we were at home? What is this, a time machine? Is your function a time machine? And here's the problem with functions. They don't do this. This is impossible for a function. You can't have two x's be the same x while they give you two different answers. You guys ever get caught lying to your parents? I mean, probably not you, but you've heard of a story where someone got caught lying, right? And they say, oh no, I was at home. 2 o'clock, I was at home, right? And instead they said, oh, but we saw you at school. What the crap? So where were you? Were you at home or were you at the school? Because this is not possible for functions. Let me pause for a moment. Oh, never mind. So here is the thing about functions. They have a relationship, but sometimes relationships actually don't make sense. And in this case, how can 2 be in 2 places at the same time? So this is not a function. I want you to go back to look at our first example on the left. At 2 o'clock, I could be at home, right? And at 4 o'clock, I could be at home. So your output values can repeat. But what can't repeat are your input values because it doesn't make any sense. At 2 o'clock, you're at home, and at 2 o'clock, you're also at school. Unless if you're homeschooling, like we all are right now, distance learning, that doesn't make any sense. So that's a catch when it comes to these problems, is that if they repeat in the input value, it's not a function. Okay? So let's go ahead and do one more thing here. We can graph these, domains and range. We said 2 goes where? 2 goes to what number? 2 goes to 1. So 2 goes to 1. 3 goes to 4. 3 goes to 4. Here's 4. Our y value is 4. Remember, these are always our x's and our y values. And 4 goes back to 1. 4 goes back to 1. So the thing about algebra is we're learning all these different possible ways of representing the same exact thing. A function tells us all the possibilities. It's just an equation we can use. And we can plug in values to reflect that. So we can see what numbers work. So the range is the only one that can repeat. That is right. The range can repeat, but the domain can't. Our x values, imagine this. I told you I was at 2 and at 2, but I was at 1 and 3. So let's think of this as dating. Okay, no, we shouldn't do that. No, never mind. I was going to say this is dating, but no, this would be bad. Okay. Let's see. Okay. Do we have any questions right now? I'll take questions. Okay, so let's look at the homework today just for IXL. So they're just having you look at our ordered pair, 6, 4, look, 6 and 4. 6 and 4. 6 is my x, y, 4 is my y, 6, 4. 18, 17, 18, 17, 16, 3, 16, 3. Now who was 5 with? 5 was with 16. Sorry about that, I jumped on you guys. So you're just gonna fill out the table. It'll be super fast. Submit. Okay. Now this one is a graph, which looks very similar to what we were talking about in our lesson. So let's look at these labels. Let me go ahead and screenshot this. Just write on it. So I'm going to go ahead and just write down these values. We have 1, so that's 1, comma 4. Up here, it's 2, 2, comma, that looks like 9. This is 3, comma 5. And this is 10, comma 6. So to fill out the graph, we have something 5. Something 5 is 3. We have 2, 9, 2, 9, 2, 9. We have something 6. Something 6. Look at 6. What's something 6? Oh, that's 10, 6. 1, 4. 1, 4. Yep, we got that. So you're going to fill out the missing points on the table. That was exactly the same thing. Same thing. Same thing. Okay, this is just really the same thing. This one became more difficult because there's more points. You guys are going to go to 95 in this one. And this one is, you guys are going to fill out all the points. So just do one at a time. So I'm doing one at a time. We're going to look at, let's do this one first. This is -4, comma, that looks like 1, positive 1. Over here, let's do this one here. That is -1, -2, -3, comma, what's your y value? Or y value is 0. So be careful about that. I'm sitting on the floor. I'm not +1 up or -1 down. Let's do this one up here. That is also -3, right? Same line, -3. And this is going to be +3. Down over here, I see the x value. What's the x value? Ordered pair. Ordered pair x and y. X is at 0, but y is way down here at -4. Over here, I see it's 1, 2, 3, 4, 5, and up 2 spaces. 5, 2. You can double check it. 5, 2. Yep, that's where they go. And up here, you can barely see it. That's going to be 5 because it's the same line as 5. That's probably going to be 5. Okay. All right. So working on tables and the relationship on this function. Not really necessarily a function. This is just graphing points. Okay. So one last part I want to go ahead and talk about is function notation. This will take me only a couple of minutes. And we talked about f of x when we first started, okay? F of x. The idea here is this is function notation. And we said f of x is actually just a way of saying y. Now, let me go ahead and show you that real quickly back at the top. Look at these two problems. They look almost exactly the same, except I swapped y for f of x. And why would we do that? Don't we have y already? Now here's the reason why. You ever see someone eating? You're like, hey, what you eating? And what does that guy do? He doesn't tell you what he's eating. He shows you what he's eating. He opens his mouth. Ah. Little kids do that, don't they? You're like, oh my gosh, he's eating Oreos. So that's really what we're doing. We're showing you what we're plugging in. So if I say f of x is equal to 2x plus 1, let's use this example. And I say f of 3 What this means is all the x values have now become 3. I'm showing you what to plug in. Plug in x as 3. Plug in x as 3. So what is f at 3? F at 3 is equal to, that's 6 plus 1 is 7. F at 3 is 7. This is no different than me just saying y is 7 when x is 3. This is no different than me writing 3 comma 7 as an ordered pair. It's all the same meaning. The only difference here is, take a look. We can see what you're plugging in. If I wrote y is equal to 2x plus 1, you would write x equals to 3, and then you would just write in y is equal to 2 times 3 plus 1. Okay? But you don't see it here. You just see the letter y. So people thought, wouldn't it be nice to see what you're plugging in? And the idea of a function is that's my machine. I'm plugging 3 into my machine. Plugging 3 into the machine, into that smoothie maker. If I say f of 10, okay, same function. So it's 2. We're now going to plug in what? X became what number? X became the number 10. So we know this becomes 20 plus 1 is 21. So you can write on your ordered pair, it's 10, 21. You could write using function notation, f of x. When I plug in 10, you will get 21. You can write this as an ordered pair. So whenever you see the letter f, it just means here's your function. Now plug in what? 2 times what? Plus 1. You tell me what you want to plug in, we can plug it in. It's almost like a roller coaster. That's just a seat. You fill in the seat and then you go for the ride. So fill in what? Let's plug in a 5. Let's go for a ride. That's 2 times 5 plus 1 is 10 plus 1 is 11. We just went for a ride. Our input was 5. Our output was 11. Okay, so in iExcel, you'll see just problems that look just like this f function. And they'll tell you what to plug in. So go ahead and plug it in. Okay.